Hello.
Hello, sir.
No, I still can hear you. No, beta, there is very
Hello.
lot of disturbances. Am I audible clearly?
Yes, sir.
You can chat, tell on chat if I'm audible or not. Okay, then can you please check your mic, or shall we start? You can talk to me through chat.
Hello. Hello.
Yeah, your voice is coming, but it's very low, very low.
So can you check your speaker?
Not able to figure out what you are saying, Imran. Okay, let's start. No, I'm using Bluetooth and yeah, it is clear. Okay, let's start. You can talk to me on chat if you got any doubts or anything. Okay, let's start the chapter. Is that all right? Okay, let's start matrices. So where is chapter? Wait, okay, matrices. Okay, what is a matrix? A matrix is an arrangement of things, right? It doesn't have any value. It's just an arrangement. If I write 2 1 3 1 2 3 3 3 3, this is a 3 by 3 matrix, right? This is called the order of a matrix. It has 3 rows and 3 columns. We write it like this: 3 rows, 3 columns. So rows is always first, column is always last. Rows and column. Okay. So this is an matrix. It doesn't have any value. This is just a way to represent numbers. How the numbers are represented. It can be of any order like this. It has 2 rows and 3 columns. It can be like this also: 1 row, 3 columns. It can be like this also: 3 rows, 1 column. Right? This is what a matrix is. I think you know this, all this, right? Is that yes? Okay. So let's start. Transpose of a matrix. What does transpose of a matrix mean? You can write down if you want. Changing the rows with the columns is called transposing the matrix. All right. Let me give an example. If there is a matrix, A 2 2 2 3 4 5 6 7 8 9 10. Then A transpose, we write it like this: A T, right? A transpose superscript. T is the superscript. A T. Take the first row write it in the first column. This is row 2, 3, 4. We write it like this: 2, 3, 4. Then take the second row, write it in second column: 5, 6, 7. Take the third row, write it in the third column: 8, 9, 10. Done. This is called the transpose of a matrix. Are we clear? Okay. So in transpose of a matrix, let me give another example. Take transpose to this: 1, 2, 3, 4, 5, 6. It has 2 rows and 3 columns, right? So the A transpose would be: take the first row, 1, 2, 3. Take the second row and write it on the column: 4, 5, 6. So the difference here is it has 2 rows and 3 columns. We have here 3 rows and 2 columns, right? This is the biggest difference you have in transpose. If a matrix A has m cross n order, then A transpose would have n cross m order. Are we clear on this? If it has m rows, then it will have n rows. If it has n columns, it has m rows, m columns. Suppose it has m and n, m rows and columns, it will have n rows, m columns. Are we clear? The order will change. We're clear, Imran? Okay. So let me give you a question. How are you going to tell me the answer? But can you find A transpose? Tell me the order of A transpose and A transpose. These three you have to tell. Yeah, vertical, right? Yeah, it is a vertical matrix, and the column would be, yeah, these numbers will be in the column. Yeah, the first is 1 row, 3 column. The transpose would be order of transpose 3, 1, right? And A transpose would be -5, 6, 8, right? Yeah. Okay. Very easy. Do you know how to multiply matrix, two matrices? Do you know how to multiply two matrices? Okay. If they don't have same dimensions, then if I ask you to do this is 2, 3, then we'll have can we multiply these two? No, no. You are wrong there, Imran. If we multiply two matrices of order 1 cross 3 and 3 cross 1, then it will not become 3 cross 3. See, here we cannot multiply this two. To multiply two matrices, see, If the first matrix has an order of m cross n, then the second matrix has to have the order of n cross some q. These has to be same to the multiplication to be able to be qualified, right? If you multiply two matrices, then this has to be the orders m cross n, then n cross something, n cross p, n cross q. Like if you're multiplying 2 cross 3, then the second matrix has to have the order 3 cross 4 or 3 cross 2 or 3 cross anything, right? These number has to be same, and the resultant matrix would have the order this m cross q. Are we clear, Imran? Okay, let me give you a question. Multiply can we multiply these two? Yeah, and the resultant matrix would have the order. Absolutely right. Please tell me the answer. Do you have the option to write on the board? No. Okay. Okay, you can tell the answer, then I'll solve it for you. You tell me if it's right or not. Try speaking to. Maybe I'm audible. You're audible now. Oh, you want to use calculator on this? Does your school allow you to use the calculator? If yes, then yes, you can. If okay, then you can use calculator. Why are you needing? Oh, you want to calculate the matrix multiplication in calculator or just the multiplication of the numbers? No, no, no. You cannot multiply the matrices in calculator. That you have to do by yourself. If you want to multiply the numbers like 2 into 3 or 4, that's okay. In fact, you shouldn't need calculator in this. If you are not able to solve this without calculator, then okay. 4 plus 2 plus 2 16, right? 15 plus 6 21 and 14 35, right? 16 plus 10 26 plus 32 20 plus 30 50 so 92. Yeah, absolutely right. So you get the multiplication of matrix, right? Let me give you an okay. I'll write the middle steps. Just, what we have to do is row 1 into this. Okay, see, we know that this 4 by 4 matrix, So what I'll do this, first member of this, 3 into 4 plus 1 into 2 plus 2 into 1. What I did was multiply this row with this column. 3 into 4, 1 into 2, 2 into 1. Okay, this is the first element of this matrix. The second element would be this 3 into 5, 1 into 6, 2 into 7. 3 into 5 plus 1 into 6 plus 2 into 7. This would be the third. 4 into 4, 5 into 2, 6 into 1. 4 into 4 plus 5 into 2 plus 6 into 1. This element, second row, second column, 2, 2 element with 4 into 5 plus 5 into 6 plus 6 into 7. All right. Are we clear? Okay, you want to put it this one first. Let me tell you about that. See, if you had 4, 5, 6, 7, 8, 9, 4, 5, 4, 6, 8, 5, 7, 9, suppose. This is 3 into 2. This is 2 into 3. Yes, you can multiply them, right? What will you do? Row 1. First tell me what will be the resultant matrix, the order of resultant matrix. Three cross three, absolutely right. So let's try a 3 cross 3 matrix. Now take the first row, multiply this with the first column. 4 into 4, 5 into 5. Give me a second now. Yeah, Imran. Take this row. Okay, you got it right. So let me give you a question of the book. The matrix M is given by 3, 1, 4, 2, minus 2, 0. Right? Find option A is M transpose B, M transpose M, C, M transpose. These three you have to calculate now. You don't have any doubts with multiplication, right? For transposing the matrix. Okay, you are telling me the answer of. Okay, okay. Right. Option B. Right, absolutely right. So let's move forward. Now let's try to calculate determinant of a matrix. Right, you should know that a matrix has no value, yet the determinant of a matrix has some value, some number. Determinant is a number, right? Matrix can have any quantity in it. Determinant only has numbers, right? Okay, so let's start. Can you solve this determinant 2, 3, 4, 5? Can you tell me the answer of this? This is a determinant. Can you hear me, Imran? Okay, you cannot tell the answer. See, determinant, how we calculate is take the first number, right? First choose any row or any column. That's your choice, completely your choice. Okay. Let me take this row. I'm going to calculate this determinant by taking this row as my base point. Now take the first element of that 2. Now remove this column and this row. What is the number left? 5. So multiply this with 5. Minus. After a plus, we write minus. Now this number, next number, 3. Now cross this row, this element. We have 4. 4. This is the answer. 10 minus 12 to minus 2. Or if I give you a trick, that means 1, 2, 3, 4. Just multiply these two minus this 2. 4 minus 6. This is the answer. This is okay. Okay, you got it right. Okay. Now we are going to learn how to calculate the determinant of a matrix of 3 by 3 order. See, a matrix has determinant only when it is a square matrix, right? A matrix which is like this cannot have a determinant. First of all, there is no determinant of this matrix. A matrix has only determinant when it's a square matrix. So now we are going to calculate how to determine the value of the determinant of a square matrix of order 3 by 3. 2, 4, 5, 1, 2, 3, 3, 1, 2. Suppose this is a determinant. How to calculate the answer? Okay. Similarly, like we did before, how to add a page here. Here, okay. See, take any row. I start by this. You can take any column also. It doesn't matter. I start by this. What is the first element? 2. So write down 2 into brackets. Remove the rows and columns having 2 in it. What did we have? 4 minus 3. Oh, what are you saying? 5? 4 into 4. Yeah, we can calculate. Oh, you know how to solve. There is no 4 into 4 in your syllabus. Only determinants of 3 by 3. So if you know 3 by 3, then let me give you a question. Okay, is that all right? No, let me check if you have, if you can actually solve it. Can check exercise 6b. Okay, let me tell you. If a determinant of a matrix is 0, then it's called singular matrix. If a determinant of a matrix is 0, then it's called singular matrix. All right. You can try 6b, question number 3. Okay, 6b, question number 3. All right. You have the right answer. It's 17. Absolutely right. Okay. So moving on, finding the inverse of the matrix. Do you know how to find the inverse of a 2 by 2 matrix? Do you know how to find the inverse of? Yeah, I got it. Okay, let me revise it. If we have a matrix 1, 2, 3, 4, to find the inverse 1 upon determinant A, and here I have to find the cofactor transpose like this. 2, 1, minus 3, minus 4. Do you remember? Or you want me to like revise it step by step? Okay, so you can calculate, right? Let me just give you a small question. Find the inverse of this matrix. Yeah, determinant is minus 16. Absolutely right. Okay, this is 2 minus 5 minus 6 minus 1, right? Sorry, did I change this also? This is not changed. Minus 6. This will be divided by 1 upon 16. So you will get 1 upon minus 8, 1 upon 16 divided by 2, right? 3 upon 8 minus plus 5. Yeah, right. So I think we are clear with inverse of 2 by 2 matrix. Now calculating inverse of 3 by 3 matrix. To calculate that, first we need to know what minor of a matrix is. Okay. What does minor of a matrix mean? If there is a matrix 2, 1, 3, 4, 5, 6, 1, 2, 3, then if they ask you to calculate minor of 5, 5 this is this element. If they ask you to calculate minor of 5, then what to do? Take the 5, remove the column and the row involving 5. Wait a minute. What is it? Background. Just wait. Is it clear now? Yeah. If they ask you to calculate minor of 5, so remove the column and row containing 5. Then multiply like this, right? 2 into 3, 6 minus 3. This is the answer. Okay, minor of 5 is 3, right? Are we clear? See, 6 is 2 into 3. What did we have here? See, let me rewrite it. 2, 1, 3, 4, 5, 6, 1, 2, 3. This was the matrix, right? I had to calculate the minor of 5. So remove this row, this column, and this row. After that, whatever remains, calculate the determinant of that. 2, 3, 1, 3. This is the minor of 5. Okay. The answer of this is 3. Are we clear? Yeah. So can you calculate the minor of 3? This 3. Yeah, right. Absolutely right. So I think we are clear with minus. Okay. The first step to calculate the inverse of any matrix is to calculate the determinant of that matrix. If determinant A is equals to 0, then inverse cannot be calculated. Okay. If determinant is 0, then inverse cannot be calculated. Okay. The second step, always you can write down. First step is determinant A, right? First step is determinant A. Second step, form minor matrix. We'll represent this as M. Okay. Form minor matrix. What does this mean? That if you have a matrix 2, 3, 5, 4, 6, 7, 1, 8, 9. Suppose you calculated the determinant and it's not 0. What the second step is, form the minor matrix. What this means is a matrix containing the minors of these numbers. The minor of 2 is determinant 6, 7, 8, 9. The matrix, the minor of 3 is 4, 1, 7, 9. Determinant this. The minor of 5 is 4, 1, 6, 8. Determinant. The minor of 4 is 3859. I know this is very lengthy, yet we have to do this. 6 is 2519. Of 7 is 2138. Like this. You have to calculate all the minors. Of 1 is 3657. Of 8 is 2457. Of 9 is 2436. You have to calculate all this, then form this matrix. Are we clear? Yeah, minor is not like determinant of that number. Minor is the determinant of the remaining number after we cancel the row and the column of that number. Like if you have to calculate the minor of 2, then remove this row, remove this column, whatever remains, determinant of that. Okay, we clear? So you have to you have to calculate minor of all the numbers and form a matrix. The minor of 2 goes here, minor of 3 goes here, minor of 5 goes here, minor of 4 goes here. You get the point, right? Yeah, so let's calculate. I'm solving by giving an example. You also calculate. This is 54 minus 56. This is minus 2. This is 36 minus 7. Arrow. 29. 36 minus 7. 32 minus 8. 32 minus 8, right? No, 6. 26. 27. This is 5. Minus 40 is minus 13. 18 minus 5 is 13. 16 minus 3 is 13. 21 minus this is 6. Yeah. 21 minus 30 is minus 9. 14 minus 20 is minus 6. Yeah, this is 189. 189. And this is 12 minus 12 is 0. Tell me when you get this matrix. All right. This is the matrix of the minors of the given matrix. This is the given matrix. Okay. Just calculate all this, then text me. Have you solved it, Imran? Okay. So you get this matrix, right? The next is this one. This is 29. Have you got this matrix? Okay. This is called M, the matrix of minors of that given matrix. Right? We calculate all the minors, formed a matrix here. Now we have to calculate the cofactor matrix, right? We have to form a cofactor matrix. How we do that is, the question is find. We are trying to learn the finding inverse of the matrix. These are the steps I'm telling you. Yeah, M is the formed minor matrix of all the minors, right? This is the second step. First we have to calculate the determinant. Second is to calculate M. M is the matrix formed by putting the elements as the minors of the question. Okay, right? The third step is to calculate the cofactor matrix. Cofactor matrix is very simple. Whatever you have there, just change the signs of this. Okay, just change the signs of this, and this will be the cofactor matrix, right? This will be called C. C will be -2, -29, 26. I just change the sign of 29. This will be 13, 13, -13. I change the sign of this and this. This is 960. I change the sign of 6. Are we clear? Just change the signs of these numbers. What you have there is a cofactor matrix. Cofactor matrix. We denote it as C. Are we clear? Are we clear? Okay. So did you get the cofactor matrix? This is the cofactor matrix. I just changed the signs of this, right? Remaining is exactly the same, right? Are we clear till now? No, this is 9, 6. So let me see. No, this was 9 minus 60, right? 9 minus 60. Did I calculate it wrong? Let me check. 14 minus. No, I think I got 6 minus 6. See, this is 14 minus 20, right? 14 minus 20. Yeah, this is 14 minus 20. Bottom left, this 21 minus 13. Yeah, minus 9, right? Oh, sorry. This is minus 9. Okay, got it. This is minus 9. Yeah, right. I left the minus there. Okay. So till now we are clear. Okay. Now calculate the cofactor matrix by transpose of cofactor matrix. Just transpose this matrix. We just learned how to calculate the transpose of a matrix, right? So this will be -2, -29, 26, 13. Yeah, top row becomes column, and in that order, all the rows become columns. -6, 6, 0. This is what we get. This is fourth step, right? We are clear? All the 4 steps. Now the fifth step. This is called transposing the cofactor matrix. We calculated C. Now we are calculating C transpose. This is fourth step. Fourth, right? Now fifth step, the final step, A inverse. A is the inverse matrix, right? Is 1 upon determinant A C transpose. C transpose is the matrix we just calculated. Okay. So this is how you calculate. Okay, let me solve this also. Putting this on the formula. First calculate the determinant of that matrix and tell me what we have. Divide this number by the determinant and you will have the answer. Right? Determinant of the question, given question, this. Determinant of this. Determinant of the question. Determinant of the question given. This is A matrix, right? The matrix of which you have to find the inverse of. Determinant of that. The given question, the first matrix that was given to you, right? Determinant of A. A was the question given to you to find the inverse. 2, 3, 5, 4, 6, 7, 1, 8, 9. In determinant of this 39. Okay. So now divide this cofactor matrix by the determinant of A and you have the answer. This is the inverse of A. Are we clear? Are we clear? ठीक है. Are we clear? Okay. So to determine the inverse of a matrix, there are 5 steps. First step is to calculate determinant A, then calculate M, right? Minor matrix. Third is calculate C, cofactor matrix. Fourth is C transpose. Fifth is C transpose upon determinant A, right? We are clear? Are we clear, Imran? Yeah, right. No, you can tell me the answer. Yeah. Okay. So you can try all these 3 exercises till the next class. Okay. Other people are waiting for another class. Okay. And if you have any doubts, please ask me in the next class. Okay. And in the next class, we'll finish this chapter. All right. Okay. Bye.